We think about our senses, most of us immediately recall the classic five: sight, hearing, taste, smell, and touch. But did you know that humans actually possess a much broader range of sensory abilities? In this video, we'll journey beyond the basics and explore the fascinating world of human sensory systems. From the subtle sense of balance to the awareness of body position, our bodies are equipped with remarkable tools for interpreting the world. Let's begin by understanding why the traditional five senses are just the tip of the iceberg and set the stage for a deeper dive into the hidden wonders of human perception. Before we move into the lesser-known senses, let's briefly revisit the five that everyone learns about in school. Sight allows us to perceive light and color, hearing lets us detect sound waves, taste helps us enjoy flavors, smell brings us the aroma of our environment, and touch gives us information about pressure, temperature, and pain. These senses work together seamlessly, helping us navigate daily life. However, as science has advanced, researchers have discovered that our sensory experience is far more complex than previously thought. Now, let's explore what lies beyond these familiar sensations. Beyond the five senses, our bodies possess additional sensory systems that operate quietly in the background. These hidden senses are essential for our survival and daily functioning, even though we may not always be aware of them. For example, have you ever wondered how you can touch your nose with your eyes closed or maintain your balance on a moving bus? These abilities are thanks to specialized sensory systems that constantly provide our brains with vital information. In the next scenes, we'll uncover these remarkable senses and see how they shape our perception of reality. Start with proprioception, often called the sixth sense. Proprioception is our body's ability to sense its own position, movement, and action. Thanks to this sense, you can walk without looking at your feet, type on a keyboard without watching your fingers, or even touch your ear with your eyes closed. Specialized receptors in our muscles, tendons, and joints send constant feedback to the brain, allowing us to move smoothly and coordinate complex action. Without proprioception, even simple tasks would become incredibly challenging. Another crucial but often overlooked sense is the vestibular sense, which helps us maintain balance and understand motion. Located in the inner ear, the vestibular system detects changes in head position and movement. This sense is what allows you to ride a bike, stand on one foot, or recover your balance after tripping. When the vestibular system is disrupted, you might feel dizzy or disoriented. It works closely with our vision and proprioception to keep us upright and coordinated, especially during complex activities. Thermoception is our ability to sense temperature changes. Specialized nerve endings in our skin detect heat and cold, sending signals to the brain so we can respond appropriately. This sense helps us avoid dangerous situations like touching a hot stove or stepping into freezing water. Thermoception also plays a role in comfort, letting us know when to put on a jacket or seek shade on a hot day. It's a vital part of our sensory toolkit, protecting us from harm and helping us adapt to our environment. Nociception is the sensory system responsible for detecting pain. When your body experiences injury or potential harm, specialized receptors called nociceptors send warning signals to your brain. This sense is crucial for survival, as it prompts us to withdraw from dangerous situations and seek healing. Pain isn't just a feeling, it's a complex process that helps protect our bodies from further damage. Without nociception, we might not notice injuries until it's too late, making this sense essential for our well-being. Interoception refers to our ability to sense internal bodily states. This includes hunger, thirst, heartbeat, and the need to breathe. Interoceptive signals come from various organs and tissues, constantly informing the brain about what's happening inside our bodies. This sense helps us maintain homeostasis or internal balance by prompting us to eat, drink, or rest when necessary. Interoception also plays a role in emotional experiences, linking physical sensations to feelings like anxiety or excitement. Equilibrioception is our sense of gravity and spatial orientation. Closely related to the vestibular system, the sense allows us to know which way is up or down, even with our eyes closed. It's what helps astronauts adjust to weightlessness and enables us to stand upright on uneven ground. Equilibrioception relies on input from the inner ear, eyes, and proprioceptive feedback, working together to keep us oriented in space. Without it, simple movements would feel disorienting and confusing. More common in animals like birds and turtles, some research suggests that humans may have a limited ability to sense magnetic fields, known as magnetoception. Though not as developed as in migratory species, subtle magnetic sensitivity could play a role in our sense of direction or navigation. Scientists are still exploring how this sense might work in humans, but it's a fascinating example of the hidden potential within our sensory system. Chronoception is our sense of the passage of time. While we don't have a specific organ dedicated to this sense, our brains are remarkably good at estimating durations, intervals, and timing. This ability helps us manage daily routines, anticipate events, and coordinate movements. Chronoception is influenced by attention, memory, and even emotions, making our perception of time a complex and dynamic process. It's another example of how our sensory systems extend beyond the obvious. Chemoreception is the ability to detect chemical stimuli in our environment. While taste and smell are the most familiar forms, chemoreception also includes the detection of carbon dioxide levels in our blood or the presence of irritants in the air. This sense helps us avoid harmful substances and maintain internal balance. Chemoreception is vital for survival, allowing us to respond to changes in our surroundings and protect our health. Echinoreception refers to our ability to sense mechanical changes, such as pressure, vibration, and texture. Specialized receptors in our skin and tissues detect these stimuli, allowing us to feel the difference between a gentle touch and a firm handshake. Mechanoreception is essential for tasks like typing, playing musical instruments, or even walking on different surfaces. It adds depth and detail to our sense of touch, making our interactions with the world more nuanced. Reception is the sense that allows our bodies to detect changes in blood pressure. Specialized receptors in our blood vessels monitor pressure levels and send signals to the brain, which then adjusts heart rate and blood vessel diameter to maintain balance. This sense operates automatically, helping to keep our circulatory system stable and ensuring that vital organs receive enough blood. Proprioception is a perfect example of how our sensory systems work behind the scenes to keep us healthy. Osmoception is our body's ability to sense changes in water and salt balance. Specialized cells in the brain detect shifts in blood concentration, prompting us to feel thirsty or adjust fluid retention. This sense is crucial for maintaining hydration and electrolyte balance, especially during exercise or illness. Osmoception ensures that our cells function properly and that we stay healthy, highlighting the intricate ways our bodies monitor internal condition. Stretch receptors are specialized sensors in our muscles and tendons that detect changes in muscle length and tension. These receptors provide feedback to the brain, helping us maintain posture, coordinate movement, and avoid injury. For example, when you lift a heavy object, stretch receptors signal how much force is needed and when to stop. This sense works closely with proprioception, ensuring smooth and controlled movements throughout the day. Photoreception is our ability to detect light, which forms the basis of vision. Specialized cells in the eyes called photoreceptors respond to different wavelengths of light, allowing us to see colors, shapes, and movement. Photoreception is not limited to conscious vision. It also helps regulate our sleep-wake cycles and mood by detecting changes in ambient light. This sense is fundamental to how we interact with the world around us. Auditory perception goes beyond simply detecting sounds. Our brains analyze pitch, volume, direction, and rhythm, allowing us to enjoy music, understand speech, and recognize environmental cues. This sense also helps us locate where sounds are coming from, which is vital for safety and communication. Auditory perception is a complex process that involves both the ears and the brain, highlighting the sophistication of our sensory system. Gustation, or the sense of taste, allows us to detect sweet, salty, sour, bitter, and umami flavors. Taste buds on our tongues contain specialized cells that respond to different chemicals in food. Gustation works closely with the sense of smell to create the rich experience of flavor. This sense not only brings pleasure but also helps us avoid spoiled or harmful foods, playing a key role in nutrition and survival. Olfaction is our sense of smell, which detects airborne chemicals and sends signals to the brain. The olfactory system is highly sensitive, capable of distinguishing thousands of different odors. Smell is closely linked to memory and emotion, often triggering vivid recollections or feelings. Olfaction also plays a role in detecting danger, such as smoke or spoiled food, making it an important part of our sensory experience. Itch or proprioception is a distinct sensory experience separate from pain or touch. Specialized nerve fibers in the skin detect irritants and send signals to the brain, prompting the urge to scratch. This sense serves a protective function, helping us remove harmful substances or parasites from the skin. While often annoying, the sense of itch is another example of the body's intricate sensory network. Our bodies can detect vibrations through specialized receptors in the skin and tissues. This ability helps us sense the texture of objects, feel the rumble of a passing train, or enjoy the rhythm of music. Vibration sense is important for communication, especially in environments where sound is limited. It adds another layer of detail to our tactile experience, enriching our interaction with the world. In addition to detecting pressure and vibration, our bodies can sense stretch and tension in muscles and tendons. This sense helps us gauge how much force to use when lifting objects or performing delicate tasks. It also plays a role in injury prevention, signaling when a muscle is being overstretched. Stretch and tension sensing is closely linked to proprioception, ensuring smooth and safe movement. Bodies are equipped to detect changes in atmospheric and internal pressure. This sense is especially noticeable when flying in an airplane or diving underwater, where pressure differences can cause discomfort or pain. Specialized receptors in the ears and other tissues help us adapt to these changes, maintaining equilibrium and protecting delicate structures. Pressure sensing is another example of the body's remarkable adaptability. Hunger and thirst are sensations generated by interoceptive signals from the body. When our energy or fluid levels drop, the brain receives messages prompting us to eat or drink. These senses are vital for survival, ensuring that we maintain proper nutrition and hydration. Hunger and thirst are influenced by hormones, blood sugar levels, and even psychological factors, making them complex and dynamic experiences. We can often feel our own heartbeat or notice changes in our breathing, especially during exercise or moments of stress. These sensations are part of interoception, providing feedback about our cardiovascular and respiratory systems. Being aware of heartbeat and respiration can help us manage stress, improve athletic performance, and recognize signs of illness. This internal awareness is another layer of our sensory experience. Sensation of fullness after eating is another example of interoception. Stretch receptors in the stomach and signals from digestive hormones inform the brain when we've had enough to eat. This sense helps regulate food intake and maintain a healthy weight. Disruptions in satiety sensing can lead to overeating or eating disorders, highlighting its importance for overall well-being. Our bodies have specialized sensors that detect when the bladder or bowels are full, prompting the urge to use the restroom. These sensations are part of interoception and are essential for maintaining hygiene and health. The ability to sense these internal states develops in childhood and is crucial for daily functioning. It's another example of how our sensory systems keep us informed and in control. Though we can't directly feel our blood sugar levels, our bodies have mechanisms to detect changes and respond accordingly. When blood sugar drops, we may feel shaky, hungry, or weak. These sensations are part of the body's internal monitoring system, helping us maintain energy balance. For people with diabetes, being attuned to these signals is especially important for managing health. Bodies constantly monitor levels of oxygen and carbon dioxide in the blood. Specialized chemoreceptors in the brain and blood vessels detect changes and adjust breathing rate as needed. This sense ensures that our tissues receive enough oxygen and that waste gases are removed efficiently. It's a critical part of our respiratory and circulatory systems, operating automatically to keep us alive. When our bodies experience inflammation or injury, specialized sensors detect chemical changes and send signals to the brain. These sensations can include pain, swelling, or warmth, prompting us to rest or seek treatment. Sensing inflammation is part of the body's defense system, helping us recover from illness or trauma. It's another example of the complex ways our sensory systems protect us. Bodies can sense immune responses such as fever, chills, or fatigue during illness. These sensations are generated by chemical signals released during infection or inflammation. They prompt us to rest and recover, supporting the healing process. Sensing immune activity is an important part of interoception, helping us recognize when something is wrong and take appropriate action. Emotions are closely linked to physical sensations. For example, anxiety might cause a racing heart, while excitement brings butterflies in the stomach. These feelings are part of interoception, connecting our mental and physical experiences. Being aware of emotional states helps us manage stress, build relationships, and make decisions. It's a reminder that our sensory systems are deeply intertwined with our emotion. Humans are highly social creatures, and we have specialized senses for detecting social cues. These include interpreting facial expressions, tone of voice, and body language. Social sensing helps us navigate relationships, communicate effectively, and build trust. It relies on a combination of visual, auditory, and emotional perception, showcasing the complexity of human interaction. Our sense of temperature isn't limited to the environment. It also helps us enjoy food and drinks. We can detect when soup is too hot or ice cream is refreshingly cold. This ability protects us from burns or discomfort and enhances our enjoyment of meals. Temperature sensing in the mouth is another example of how our sensory systems work together to keep us safe and satisfied. Texture is a key part of our eating experience. Our sense of touch in the mouth allows us to distinguish between crunchy, smooth, or chewy foods. Texture sensing adds depth to flavor and can influence our preferences and satisfaction. It's another example of how multiple senses combine to create a rich and enjoyable experience. We can sense the movement of air across our skin, whether it's a gentle breeze or a strong gust of wind. This sense helps us detect changes in the environment, such as approaching storms or open windows. Airflow sensing is important for comfort and safety, adding another dimension to our perception of the world. Our skin can detect sunlight and ultraviolet UV exposure, prompting the production of vitamin D or causing us to seek shade. This sense helps protect us from sunburn and supports overall health. Sunlight sensing is another example of how our bodies interact with the environment in subtle but important ways. Humans may have a limited ability to detect pheromones, chemical signals that influence social and reproductive behaviors. While this sense is more pronounced in animals, research suggests that subtle chemical cues can affect human attraction, mood, and bonding. Pheromone sensing adds another layer to our complex social interactions. We can sense when we're tired or full of energy thanks to signals from our muscles, brain, and hormones. Fatigue sensing prompts us to rest, while high energy motivates activity. This sense helps us balance work and recovery, supporting overall health and performance. It's another example of the body's remarkable ability to monitor itself. Our ability to sense environmental temperature helps us dress appropriately, seek shelter, or enjoy outdoor activities. This sense is vital for survival, allowing us to avoid hypothermia or heat stroke. Environmental temperature sensing is closely linked to comfort and well-being, influencing our choices and behaviors every day. When we swim or dive, our bodies sense changes in water pressure. This ability helps us adapt to different depths and avoid discomfort or injury. Underwater pressure sensing is important for safety and enjoyment during aquatic activities, showcasing the versatility of our sensory systems. Our bodies can detect changes in altitude and air pressure, such as when climbing a mountain or flying in an airplane. This sense helps us adjust breathing and circulation, preventing altitude sickness and ensuring comfort. Altitude and air pressure sensing is another example of the body's adaptability to diverse environments. When riding in a car, train, or airplane, our vestibular system detects acceleration, deceleration, and changes in direction. This sense helps us maintain balance and avoid motion sickness. Vehicle movement sensing is a practical example of how our sensory systems keep us oriented and comfortable in modern life. As we've seen, the human sensory system is far more complex and fascinating than the traditional five senses suggest. From detecting internal states to sensing subtle changes in our environment, our bodies are equipped with an incredible array of sensory tools. These hidden senses work together to keep us safe, healthy, and connected to the world around us. By understanding and appreciating the full spectrum of human perception, we gain a deeper insight into what it means to be human. Thank you for joining us on this journey beyond the basics.